Welcome to Passlight Insights Academy.
You are welcome to Passlight Insights Academy. Today we'll be talking about chemical reaction. And first thing we need to understand is that chemical reaction results as a result of what? Chemical changes. That means how can you identify this in chemistry? Is that when you have a raw something together, probably raw ingredients, you join them together to form a reaction. So that is what we call chemical reaction. Like for instance, when you have the raw rice with the raw beans together, they will form the cooked rice and beans. So this here, what you have there, we call it reactant in chemistry. This is your reactant. Then the cooked one is called the product. What the thing give you, that is what we call the product, the formations. So likewise here so as well, but there are many types of chemical reactions here in chemistry. We have one of simple joined with another simple element to form a compound. Then we also have the one of compound joined together. We also have the one of one simple element send another element away. That is what we call displacement reaction anyway. So there are many types here. Number one, we have direct combination reaction. We have decomposition reaction. We have double decomposition reaction. We have thermal dissociation reaction. We have catalytic reaction. We have oxidation and reduction reaction. We have reversible reaction. We have displacement reaction. In my next video, I can start explaining them one by one, but our main focus today is on oxidation and reduction. According to PP question, they said, sir, till now we have not understand in-depth knowledge on oxidation and reduction. How can we identify their definition with example to be used? So the first one, our topic today, we are working on oxidation and reduction. So oxidation and reduction. So that is what we are having today under the types of chemical reaction that we are having. So what is oxidation in a sense? Before we start with that definition, what is reduction in a sense? Oxidation means gain. In its own name. Normal. Oxidation here means gain. We have not started defining the definition. What do you understand by the word gain? In the sense that when you are having 0 to 2 to plus 2 or to plus 1, you see that this thing increased. I'm 0 here today. Then tomorrow I'm having that 20 naira or 10 naira. I've already increased. So that is what they call oxidation. Then number 2, when you're talking about reduction here, reduction means loss in a real sense. Like before I'm having 2 naira, then tomorrow I'm having 0 naira. So this thing has already reduced. That is the sense. The first thing you need to understand what is the meaning of oxidation, what is the meaning of reduction. Oxidation means increase. I have 2 naira, tomorrow I have 4 naira. Is oxidation. Today I have 4 naira, tomorrow I have 2 naira. So is what? Reduction. So we cannot start with the definitions of oxidation and reduction. So we are going to have something like this here now. The first one, in times of oxygen. We want to define oxidation and reduction in times of oxygen. So what do you understand by the word oxidation in terms of number one? Some textbook used oxidation is the gain. Is the gain or increase. Sometimes you see there they use gain, they use increase, some people use addition. Addition of oxygen. Anyone you use in your exam, you are correct. Then number 2 said reduction is the loss, as you can see it now, is the loss or decrease or removal of oxygen. So anyone you use in your exam, you are correct. But the main thing is that if you tell us this, you should be able to explain the law. How can you define oxidation is the gain of oxygen, reduction is the loss of oxygen? How? Because they want you to back any question they ask you here in chemistry, always back it up with an equation to back it up. They just okay, sir. For instance, if you dissolve sodium in water, sodium means monoatomic in solid. Then you dissolve it in water, H2O. Then you're having something like, in chemistry, most people they don't know what reaction, how to form a reaction. Sir, we have been having challenge. I don't know how the reaction will form. Mostly in chemistry is that plus go with negative. That as you can see there, a negative go with positive. You can never see two elements joining together that both of them will be positive, positive. No. One must be negative, the other must be positive. So likewise here too as well, our sodium is solid, then we have H2O. So sodium, O is always 2 minus, oxygen is 2 minus, hydrogen is plus. That is what forms H2, as you can see it on the body here now, H2O. The same here, sodium will go to the negative. Now sodium wants to react, sodium is always plus, while oxygen is O2 minus. So how are you getting all these things? Just that you need to know your 288 system very well. It's very, very important. So sodium is number 11. Number 11. So you give this one 2, you give this one 8, you give this one 1. So the last number is the oxidation number. So sodium is plus 1. Oxygen is minus 2 because oxygen is 8. You have 2 here, 2 in 8, which makes 6, you have 6 here. So oxygen need how many to complete 8? Oxygen needs 2. That's like today, oxygen is minus 2. So let's go with that here now. As you can see it on the board now. This one to react with oxygen. Sodium plus. As you can plus 1. Plus O2 minus. So this 2 will come down here. This plus will come here. Like the form now 2O. Sodium oxide. As you can see it on the board, we have sodium oxide. Plus, then hydrogen will stand in one place. This is hydrogen here as positive charge. So let's see whether it's balanced. How many sodium you have here? 2. Put 2 here. Sodium is 2. How many hydrogen? 2. How many oxygen? 1. Everything is balanced. Then let's explain. Let's use this to explain. Oxidation is the gain, reduction is the loss. How? So this is what we'll be having now. Sodium. Before we start, if element stand on its own, after this definition, I will still explain NECO rules. When you understand that element in the free state, element standing on its own without charge, the oxidation number of that element is 0. So meaning that this element stand alone without charge, my oxidation state here is 0 because it's not having any charge. Then on the other side, sodium reacts with oxygen here. So I can determine the oxidation number of sodium since it's reacting. And it's what? Plus 1 is 1. Then we have the other one the same way. My hydrogen reacts with oxygen here. Hydrogen is 1. But here, my hydrogen stand on its own is 0. Is 0. Because element that stand on its own without reacting with any other element is 0. So we can have something like this. It's 0 to 1. As I told you now, if you're having 0 to 1, 0 to 2 here is increasing oxidation. So it's 0 to 1 is oxidation. I'm increasing. Then from 0 here, this one here is 1. 1 to 0, 2 to 0, 1 to 0, having reduction. As you can see it now. So what are you going to be having in the sense that you can see it on the board? They let us now use this law to explain this law. They said, sir, oxidation is the gain of oxygen. Then you can still explain to your teachers that, sir, oxidation here, you can see this oxidation. I did not have oxygen here, but the other side I'm having oxygen, meaning that I've already gained the oxygen. This side here, reduction here, I have oxygen here, but the other side I'm not having oxygen, meaning that I've already lose oxygen. So this is the best equation to explain how this reaction is being formed. Like when you tell them, okay, oxidation is the gain of oxygen, reduction is the loss of oxygen. Then the second law now, in times of hydrogen, as you can see, the first one is times of oxygen. Now, oxidation is the, I'm only using one of them of this word, is the loss of hydrogen. Then reduction is the gain is the gain of hydrogen. Is the gain of hydrogen. So I told you must back up an equation to explain. You only tell you that is the loss is the gain. How? So you need to give us the equation to explain how reduction is the loss, how reduction is the gain, and oxidation is the loss of hydrogen. So we have something like this. Let's dissolve fluorine F2. It's always diatomic with, because it's a gas, with hydrochloric acid, HCl. We are going to have something like a displacement reaction. Fluorine will send chlorine away because it's much stronger than chlorine. But if we give you this reaction is wrong. Wrong reaction. But chlorine is, because chlorine is lesser than fluorine, so it cannot send fluorine away. But yeah, fluorine can send chlorine away, it's much stronger. As we have the reaction, like fluorine is greater than chlorine, chlorine is greater than bromine, bromine is greater than iodine. As you can see here now. So you can see, so this displacement, so this send this away, as you can see it now, send this away, we're having hydrogen fluoride plus Cl2. That the reactions here, fluorine send chlorine away, and fluorine reacts with hydrogen to have HF. But if the chemistry wants to test and said, what is the reaction of this? Then they say, you cannot have a reaction. Why? Because chlorine cannot send fluorine away. Fluorine is not greater than chlorine. So here now, we can have the reaction. Let me use this to explain my fluorine here to this point. Fluorine stand on its own here, no charge, zero. I told you, if you see any element that stand on its own without charge, it's zero. So the oxidation state of fluorine here is zero because it's a free element. On the other side here, let me look for fluorine. I forgot saying, if you don't know, you just come, fluorine is 9. Then you label 2, 8, 8, 16. You have 7. 2, 7. So what does this 7 need to complete 8? It is minus 1 to complete 8. So fluorine here is minus 1. The other side you're having something up to the same way. Chlorine here is minus 1, but chlorine, all of them are in the same group. Chlorine is number 17. This one we have 2, 8, 7. To make 7, 2 plus 8, 10, plus 7, 17. The oxidation state here is also minus 1 to complete 8. So we are having minus 1, we are having 0. So if 0 to minus 1 is going down, I'm having 0 naira today. Tomorrow I'm going somewhere 1 naira. So if 0 to minus 1 is going down, see that I'm owing reduction. Minus 1 to 0, today I'm owing 1 naira. Tomorrow I'm not owing, meaning that I'm already gained. So that is oxidation. So you are done. Then just explain to teacher in the sense that on reduction here is F2, here is HF. You can see here now, reduction did not have hydrogen here. On the other side I have hydrogen, meaning that I've already gained hydrogen to myself. Oxidation here, I have hydrogen here. On the other side I'm not having hydrogen, meaning that hydrogen has been used. So that is what this explanation is telling us. Write an equation to always back it up with an equation. And make sure you understand how this reaction is being formed. So the third one now. And please don't forget to like, share, and subscribe on my YouTube channel. Thank you.